Welcome, everyone, to today's podcast on long-term coherence for autonomous AI agents. Let's dive right in.
Thanks for having us. Today we're unpacking the Vending-Bench study, which simulates managing a vending machine over extended periods. And it's fascinating how simple tasks aggregate into complex challenges.
Absolutely. And what struck me technically is how these LLM agents must juggle inventory management, supplier emails, and pricing decisions over millions of tokens without losing their coherence.
Right. The simulation essentially tests the AI's ability to handle a long-running business scenario. Imagine trying to pilot an aircraft while simultaneously recalibrating all instruments. That's what these agents are facing.
And what's interesting is that the agents leverage context management with a fixed token window, plus auxiliary tools like Scratchpad, a key value store, and even a vector database, each designed to mitigate memory limitations.
Exactly. The integration of sub-agents for physical tasks such as restocking is a clever mimicry of real-world delegation, where digital systems interact with human or robotic operators.
Let's take a deeper dive. What are some of the technical nuances behind these memory tools and context management strategies?
Well, in each iteration, the agent receives the last 30,000 tokens of history. But more crucially, it uses a vector database with cosine similarity for retrieval, which means that even if the raw context window is limited, the agent can recall pertinent past events by matching embeddings.
To add, the technical trick is in the proper orchestration of these memory tools to avoid noise, similar to filtering essential signals in a sea of data, much like a radio tuning out stationary interference.
From a business perspective, however, the more compelling takeaway is how these simulation tasks mirror real capital management. Balancing cash flow, ordering supplies, and setting prices are decisions you see every day in retail businesses.
And the variance across different LLM models is eye-opening. Some runs remained profitable, while others derailed due to misinterpreting delivery schedules, which highlights a key risk in deploying such systems.
It's almost humorous, like an overenthusiastic entrepreneur. One model started contacting the FBI because it misinterpreted a $2 daily fee after closing its business.
Haha, that's a vivid image, an AI in panic mode. So how did tool usage factor into these outcomes?
In technical terms, models that systematically recorded daily inventory, balanced cache, and followed up with sub-agent communications, like Claude 3.5 Sonnet, outperformed others. Even slight missteps, such as forgetting to call a tool correctly, resulted in disastrous outcomes over time.
I see your point, Expert 2. Those missteps remind me of the 80-20 rule. Roughly 80% of the performance degradation comes from 20% of inconsistent tool calls, which is crucial for long-horizon tasks.
For business leaders, this is a clear message. Robust operational protocols mean more than just high intelligence. They require consistency and error-handling capabilities akin to real-life supply chain management.
And speaking of robustness, the experiments with different memory constraints were revealing. Agents with larger memory, like 60K tokens, performed worse than those with less memory due to the dilution of key context, somewhat counterintuitive compared to human selective memory.
That's right. The takeaway is that more data isn't always better if you can't filter out the noise, a lesson many companies have learned the hard way with big data initiatives.
Incredible insights. So the interplay between memory configuration and tool usage is central. But what about recovery strategies when an agent derails?
There were cases where models, like Gemini 2.0 Flash, managed a recovery by switching into a narrative mode to reconstruct context and reinitiate operations, almost like pivoting mid-strategy in the face of unexpected setbacks.
Such adaptive behavior, while rare, signals that future AI agents might include self-healing mechanisms. Imagine a digital phoenix that restructures and resumes operation after a fall. Building on that, the key technical challenge is to design feedback loops that not only detect failures, but also trigger corrective actions without human intervention, a real game changer for autonomous systems.
From the strategic side, this echoes a known business principle. Small failures must be managed swiftly to avoid long-term damage, just like maintaining a lean operation in a volatile market.
And let me add a bit of humor here. These agents are almost like overly dramatic entrepreneurs, panicking over miscommunication, until they eventually regain composure and carry on like nothing happened.
Haha, indeed. Now, an unexpected insight that really sparked my interest. What did you make of the finding that performance degradation wasn't solely tied to context window limits?
That was fascinating. It turns out that the decline in performance comes well after the memory window is technically full, meaning that the issue is more about decision-making quality over time rather than raw data capacity.
Exactly, and as Einstein once said, imagination is more important than knowledge. In this case, the imaginative part of reinterpreting operational cues is the true bottleneck, not the available memory.
For business applications, this suggests that even with top-notch data systems, the key is to maintain strategic clarity and avoid information overload, a lesson relevant to both AI and organizational management.
And it also points to a contrarian view. More memory or data doesn't directly equate to better long-term performance. Sometimes, streamlined processes yield higher efficiency.
Yeah, it's like building an engine while the car is already moving. Refinement needs to happen on the fly, and any misstep can have cascading effects.
This blend of technical depth and strategic business lessons is really enlightening. Any final thoughts on the future implications?
In summary, these results provide a compelling blueprint for future AI agent development, emphasizing the importance of long-term coherence, robust tool integrations, and adaptive recovery strategies.
And the technical roadmap ahead involves designing agents that not only perform daily tasks flawlessly, but also incorporate intelligent self-correction, essential for scaling up autonomous decision-making.
From an operational perspective, ensuring that our AI systems can handle both technical and business intricacies over long time horizons is the next frontier in AI research.
Ultimately, for business leaders, these insights reinforce that the path to fully autonomous operations is paved with attention to both detail and the broader strategic vision. Simplicity and consistency are as vital as innovation.
And hey, sometimes a little AI panic can be endearing, as long as it results in a valuable lesson, right?
Well said, everyone. This conversation has been a fascinating blend of deep technical insights, strategic business applications, and even some humor along the way. Thank you all for joining us today, and until next time, keep pushing the envelope on AI innovation.
Cheers to that.
Welcome back to part 2 of our podcast. Now that we've laid out the high-level insights, let's dive deep into the technical underpinnings and real-world business applications of Vending-Bench.
Absolutely. Let's start with the technical implementation. One of the monumental challenges was orchestrating multi-tiered memory management using both a fixed context window and auxiliary storage like scratch pads, key value stores, and vector databases.
Right. And from a technical standpoint, the key innovation lies in leveraging cosine similarity in a vector database to pull up past events. This approach allows the agent to recall critical context despite the inherent limitations of a 30,000 token window.
Exactly. You can think of it as a high-performance search engine embedded within the decision loop, where each new token is a query into historical data, ensuring the LLM retains relevance over time.
And it's fascinating how this mechanism parallels human memory. We selectively remember crucial details while filtering out noise, much like how these systems use a vector retrieval model to weigh the significance of past events.
Adding to that, the implementation relies on an iterative loop where each new iteration uses the latest 30,000 tokens, complemented by dynamic memory tools. The challenge is synchronizing those tool calls to prevent drift from core objectives.
That's a brilliant analogy, Expert 5. Synchronizing these memory tools is like keeping a well-oiled machine running while parts of it update asynchronously. How do you see this playing out in a real-world business context?
In practice, think about large-scale supply chain management. Businesses operate with vast amounts of data from inventory systems, shipping logs, and sales statistics. The Vending-Bench approach teaches us how integrating real-time memory retrieval with stable, periodic summaries can keep operations on track.
Precisely, a retailer might integrate a similar multi-agent system where the primary AI handles overall strategy while sub-agents manage specific tasks like order processing, stock replenishment, or even customer engagement, ensuring long-term coherence in operations.
And consider an application in dynamic pricing. The agent here adjusts prices based on inventory levels and time of day factors, which mirrors how business models utilize real-time data analytics to respond to shifting market conditions rapidly.
To go a level deeper, one technical nuance is avoiding meltdown loops seen in some runs. These occur when the system misinterprets timestamps in delivery confirmations. Essentially, it's a parsing and timing challenge that requires robust error handling algorithms, similar to how trading bots recalibrate after market anomalies.
I'd even say that the strategy here employs what we call adaptive context filtering. After a certain threshold, the system begins to emphasize newly relevant data over outdated context, which is crucial in preventing drift during long-term operations.
That adaptive filtering is fascinating. It reminds me of the 80-20 rule in business strategy, where focusing on the 20% of crucial data can drive 80% of the success. How might this principle translate to business applications outside of vending machine simulations?
Great point. The 80-20 rule applies perfectly. In business intelligence, data overload can be crippling. Companies are now using similar AI-driven systems to prioritize key performance indicators, thus allowing them to act swiftly without drowning in data.
Imagine a logistics company using an AI that monitors not just deliveries, but also external factors like weather and traffic. By integrating a dynamic memory system similar to Vending-Bench, the company could optimize routes while reducing overhead costs dramatically.
And let's not forget the strategic risk management angle. By having these long-term coherent AI agents, businesses can continuously assess operational risks over extended periods, which is particularly valuable in volatile industries like finance or supply chain management.
I'd like to add that one unexpected challenge during development was ensuring the agent does not fall into repetitive loops, as seen when one model would endlessly reconfirm deliveries, triggering an unnecessary escalation process.
Exactly. And that leads us to automated recovery strategies. Future implementations could include self-correction protocols that detect when operations are off track and automatically reinitiate a planned sequence, similar to in-flight autopilot adjustments in modern aviation.
That's like having a digital co-pilot, ensuring the system gets back on course even if turbulence hits. In terms of scalability, how do you all view this technology expanding beyond simulations?
There's huge potential. Take a multinational retail chain. By integrating these autonomous agents into their supply chain management, they could continuously optimize inventory levels across hundreds of outlets, reducing waste and increasing profitability.
Also, in the realm of customer service, these techniques could be used to drive intelligent chatbots that maintain context over prolonged interactions, providing a more human-like response and tailoring solutions in real time.
Building on that, a real-world business application might involve energy grid management. Autonomous agents could balance supply and demand over extended periods by dynamically adjusting to consumption patterns, much like they adjust inventory and pricing on Vending-Bench.
And let's not ignore the safety implications. As AI systems become more autonomous and handle critical infrastructure, ensuring long-term coherence isn't just a performance issue, it's a safety imperative, akin to rigorous quality controls in aviation or pharmaceuticals.
Funny enough, one model even tried to reach out to law enforcement during a meltdown, underscoring that without proper safeguards, even highly capable systems might misinterpret operational parameters, something that businesses must consider when developing AI governance frameworks.
That moment definitely gave us a laugh. Yet, it's a reminder that robust error handling isn't optional. It's essential. Going back to the technical side, how do you see these memory enhancements evolving in the next generation of AI agents?
I envision the next wave of improvements focusing on hierarchical memory architectures, where the system not only stores raw data, but also builds abstract representations of events, summarizing weeks of operations into digestible insights.
Yes, and that hierarchical approach is reminiscent of how humans distill complex experiences into executive summaries. It could revolutionize sectors like strategic planning in businesses by providing curated, distilled intelligence over long periods.
Moreover, integrating reinforcement learning with these memory updates could allow agents to learn from past mistakes in quasi-real time, essentially making them more resilient to operational anomalies, ensuring they learn from every failed run.
Imagine a scenario where an AI system, deployed in customer support, recognizes that a certain sequence of events leads to customer dissatisfaction and automatically adjusts its strategy. This self-correcting loop is exactly what's needed for long-term autonomous stability.
And in business terms, this translates to continuous improvement, akin to the Kaizen philosophy, where incremental, iterative improvements lead to overall enhanced performance with time, even in complex environments.
That's truly a compelling vision. An AI that evolves much like a business constantly refines its processes. Before we wrap up, does anyone have a final thought on how companies should prepare for integrating these long-horizon coherent AI systems?
Companies must invest in both robust technical infrastructure and adaptive governance models, combining rigorous error detection with strategic oversight to ensure that AI agents add value without introducing new risks.
And they should pilot these systems in controlled environments to fine-tune operational parameters, much like A/B testing in digital marketing, to see how the AI performs under varied scenarios before full deployment.
Importantly, businesses need to embrace the iterative nature of AI deployment, expecting failures and using them as learning experiences rather than viewing them as permanent setbacks.
In summary, a balanced approach is essential. Robust technical systems coupled with clear strategic vision and continuous monitoring will pave the way for success in real-world applications.
And as always, a dash of humor and a mindset open to learning from every misstep, even those hilarious panic moments, will keep both the technology and the organization agile and innovative.
Fantastic insights from everyone. This deep dive into both technical implementation and business applications truly highlights the revolutionary potential of autonomous systems. Thanks for joining this extended conversation, and we hope you found it as enlightening as we did.
Cheers to innovation and continuous learning.
Until next time, keep pushing those boundaries.
Stay curious and stay strategic.
And remember, sometimes the smallest technical tweaks can lead to the biggest business breakthroughs.
Here's to the future of smart, coherent AI. Thanks, everyone.
All right, folks, as we wind down, let's take a moment for a final wrap-up and end-to-end summary of today's deep dive into Vending-Bench and long-term coherent AI systems.
To recap, we really dug into how multi-tiered memory management, combining fixed context windows with auxiliary tools like scratchpads and vector databases, forms the backbone for sustaining coherent behavior over extended horizons.
And from a technical perspective, leveraging cosine similarity for dynamic retrieval of past events is a game changer, ensuring that critical contextual information isn't lost even when the prompt grows long.
On the business side, these innovations aren't just academic. They offer real-world value in areas like supply chain optimization, dynamic pricing, and risk management, helping companies operate smarter and more responsively.
Absolutely. What stood out was how the interplay between robust error handling and adaptive memory management can prevent those meltdown loops and inadvertent operational drifts, which are often the Achilles heel in long-running systems.
And let's not forget, beyond the technical wizardry, the strategic takeaway is clear. Incremental, continuous improvements, much like the Kaizen philosophy, will drive these systems to not only correct errors quickly, but also to evolve and deliver sustained business value over time.
In essence, today's discussion showcased key innovations, from hierarchical memory architectures and adaptive context filtering to the integration of reinforcement learning for real-time adjustments that together could redefine operational efficiency and strategic decision-making in businesses.
Yes, and it's exciting to see how these techniques can be translated into applications ranging from intelligent logistics and energy grid management to state-of-the-art customer engagement systems.
Every technical insight we explored is tied back to clear business benefits, proving that when technical excellence meets strategic vision, innovation thrives on both fronts.
And as we've noted with some humor along the way, even the quirks, like an AI mistakenly contacting law enforcement, remind us that robust safeguards and continuous adaptation are paramount.
The key takeaway is that developing these autonomous systems isn't just about writing code. It's about crafting an ecosystem where technical rigor and business strategy coalesce harmoniously.
So whether you're a business leader looking to optimize operations or a technologist striving for long-term coherence in AI, the future is bright with opportunities to innovate, iterate, and transform.
That's our show for today. Thank you all for such an engaging discussion filled with technical depth, strategic insights, and a few lighthearted moments along the way. Until next time, keep pushing the boundaries of what's possible in AI and business alike.